Hello, everybody. Welcome to another episode of Observable Flutter. Today, we've got a pretty fun episode leading up to Flutter Forward in Kenya. Khan, as you all have seen, her, Eric, and others have been working on a game, and they've started to showcase this effort in their new Learning to Fly Season 2. But so far, I think episode 1 is dropped. Episode 2 may be coming soon, or maybe just out. We've seen a very primitive build that is actually months old of this kind of, what's the original one called? Doodle Dash, and this is called, Dash Jump, or I don't know, something. Yeah, it's called Doodle Dash, and this is, nope, I still don't know the name of the game, but that's okay. There's a coding challenge in association with this, and we're going to work on that today by adding a feature to the Doodle Dash game. So first of all, a few notes. Oh, let me make sure I've got the chat up so I can see folks. All right, there we go. Code of conduct, everybody. We are operating under the Flutter Code of Conduct and the YouTube Terms of Service. So we definitely want to be treating each other with respect, as the Flutter community is known for. So that's certainly very important. We'll be talking about different technologies on the show, and we always want to be discussing everything with deep respect, even if we're arguing against its use. Because remember, the authors of that have put their time into those products for our use, and we always want to be respectful. So, all right, let's get started. So, first of all, hello everybody. Welcome. Stay a while and listen. I've checked out the game here, and actually let me show everyone where to find this. If you go to GitHub and you go to the Flutter Code Labs repository, and you make the screen bigger, which is really critical. First of all, this is a great repository, tons of valuable stuff, but this is the tech that sits behind different code labs that you might use on flutter.dev and around the Flutter ecosystem that are made by the Flutter team. And right down here, you'll see Flame building Doodle Dash. That's the name of the game. Oh, it's Doodle Jump, right? Doodle Jump is the name of the original game. So Doodle Dash. And in here, you can see all the different steps of the code lab. This is a little bit of a look behind the curtain, but there's a folder up here called Finished Game. And this is what I'm going to be operating in to add a feature to Doodle Dash. So I've already checked this out, and now I'm just going to close this window. And I'm sitting here in my Codelabs repo in the Finished Game directory. And, so I'm sitting here in the Finished Game directory, and we're ready to understand the game as it is and add something to it. So the first thing that I want to do is just run it. Flutter run. We'll run on Mac OS, and let's see what we're starting with, and then we'll kind of look at the code and understand it a little bit better. So I'm going to make space for the game window itself here, which is now popped in, and let's play, huh? So we'll alternate between Dash and Sparky today, but to start, we'll be Dash. And I don't know if you've played Doodle Jump, then this might look pretty familiar. We are basically just infinitely jumping up, and we're moving from platform to platform. There's different kinds of platforms. Some of them move. I don't think we've seen a moving one yet. Oh, there's a moving one, which we just kind of caught. Some of the platforms you can only jump on once. And, there's different power-ups. We got a big jump there. Actually, oh no, we jumped past that, so I couldn't demo jumping on it again. But if you ever fall off the bottom of the screen, then you lose. So that's the concept of the game. Oh, here's a little noogler hat. It's a big power up. And you can kind of go off the sides. They talked about this in the last, in the first Learning to Fly episode. And this is the game. There's different levels. It kind of keeps evolving as you get higher and higher. But it's pretty good, honestly. It's like actually fun to play. It's just hard enough where you have to be paying attention and you kind of just catch some platforms and feel good about it. Not too easy, not too hard. But if you lose, by falling off the edge like this, then you get the game over screen. So a pretty complete game, and it's our task to add a feature to it. Kimura says, how to hack my teacher's phone with Flutter. Wrong tool. Not that would be very tricky. I guess you could get your teacher to install an app that you wrote with Flutter, but don't do that. That would justly get you detention or expelled or kicked out of school, depending on how old you are. Okay, let's look at the code a little bit here. So to start, we have our lib directory here, and they covered this a little bit in that first Learning to Fly episode. But again, that was an old build. They filmed that episode quite a while ago, Eric and Con. So things might have evolved a little bit since then. So let's just kind of see exactly what we're dealing with here. So in the lib directory, there's the main.dart file, pretty standard. And again, it still starts with widgets, and then eventually you kind of pass the torch to Flame, which is, then responsible for all the gamey things. And we have a game directory. So in our game directory, it's opening everything expanded here. In our game directory, we've got a managers folder, sprites, utilities, widgets, and then a couple very high level files. Now I have just kind of poked around this code a bit already, and I know, for example, that, well, actually, let's look at, well, where's the main game? I think it's here. This is the main game class, right? Extends Flame game, yeah. So this Doodle Dash file is very important. I'm gonna glance at chat real quick here. Oh, somebody, Gabriel says, wow, this is impressive. I've completed the Code Labs tutorial of Doodle Dash. Very fast, incredible. And when I run full screen on desktop, it seems like the platform distance are too far away, making you lose the game. Oh no. That sounds like an excellent feature to add, is improved responsiveness. I've played with it a little bit, but mostly now that I think about it, with different heights of the window. I haven't really played with different widths, but I could imagine, just detecting the width, having like a base width. Maybe you say, we've calibrated our platform generation to work nicely for 500 pixel width or something. And then, at any given time, you just see what the current width is. And if it's, 750 pixels, which is 1.5 times as much as 500, then you generate 1.5 times as many platforms. That might be enough to kind of fix what you're seeing there, and could be a good feature to add to it. So incredible that you already got through the entire Code Lab. It's pretty long. Okay, so this Doodle Dash class extends Flame game, and there's already, immediately we kind of see some interesting things here. There's something called a world. We've got a level manager, game manager, and object manager. So I want to kind of visit these as we go, or to kind of get started here. So this world class, let's see, where does that come from? Oh, world.dart, which is right below us. Excellent. So I think this, we can see it's a parallax component, which is a thing from Flame. And that means, I'm guessing, yeah, this is the background in the sky kind of moving around. Oh, and the file ends quickly. So there's not a ton of actual game logic here. Yeah, this is basically just the backdrop. Oh, little follow-up here. Gabriel says the tutorial took an entire day, but was 100% worth it. Looking to complete more and more tutorials. Incredible. That's great feedback. I'm really happy to hear that. And I didn't work on that code lab at all, so I don't get any credit, but I'm very, very excited to hear that. That's great. So we have the world is the background, the stars and everything that we're kind of following, giving that sense of movement. By the way, you have to be moving really fast to see stars move. So this is actually pretty impressive how fast Dash is jumping around. Okay, so that's the world. And the level manager, I think we can maybe save that for later. Let's look at the game manager and the object manager. And this game manager comes from a game manager class in managers. Makes sense. Okay, so this is another component and it has game ref. So it's able to point back to this Doodle Dash class. Has game ref. Any component in Flame that has a game ref is able to then point back to whatever your thing was that extended Flame game. So game manager can do that. And I'm guessing, yeah, this kind of knows all the things. So it knows the score, it has our character pointer, and it has, oh, it doesn't know all the things actually. It just kind of very, very high level. Are you even playing the game? What's the score? And are you Dash or Sparky? I think that's it. I'm gonna peek at chat again. Oh, this is an interesting one. Duong asks, does Flame game have some architecture like MVC or MVVM in the application realm? I don't think it's very opinionated on that question. In my experience, I'm kind of answering this off the cuff. I've not really thought about this a ton, but I don't think Flame has a lot of opinions about how you separate your rendering from your business logic. Whether you like MVVM or MVC, I think you'll find that either of those are just fine ways to construct the insides of your game. Yeah, I don't think Flame has strong opinions about that. An unreadable name says, should I consider learning Flutter? Yes or no? I am a Python programmer. Well, that depends on whether or not you want to make cross-platform UIs from one code base that target both iOS, Android, the web, and desktop on Mac, Windows, and Linux. Because if you do, then boy, do I have the framework for you. But the things that you do with Python, you will probably continue to do with Python, if we're just being honest. So, but Flutter's great, obviously. We've got Khan in the chat today. She says, thanks for the feedback. That will be added to our list of things to work on for Doodle Dash. Are you having trouble with the horizontal or vertical distance? Oh, that is quite a good question. Well, we'll see what answer we get. Khan is the mastermind behind kind of all of the 17 days of Flutter stuff that we're seeing. And her and Eric drove this entire game and that series. And it's exciting to have her joining us today. Okay, so this is our game manager, very high level stuff. Looks good. So I'm going to close that. And this moves us to the object manager. Now, object manager, Khan, if I could offer you a tiny bit of constructive criticism, object is an extremely generic term. You could call almost anything an object manager. Well, let's see. What does the object manager do? Min, vertical distance. Oh, I think the object manager is adding, yeah, let's look at here. On mount, generate some X and Y, add a platform. Yeah, so the object manager is what's populating the game world with objects as Dash is flying upward. And in the update method, so that was all an onload, on mount. You know, I'm not gonna lie, I forget the difference between on mount and on load. Update, oh yeah, so this is gonna add our initial set of platforms here. We're seeing just kind of the first offering of platforms from the game. And then update is going to be adding some more. So here we kind of calculate the, oh, let's move the cursor there, the top of the lowest platform. And there's some interesting, like, counting goes the opposite direction with graphics. So I don't know if lowest means the lowest Y value or lowest kind of naively looking at it from a human perspective. I don't know how long we're going to have Con today, but she might be able to answer some questions for us as we go, if we've got her for longer. So there's some boundary of platform here, and tallest platform height. But then here we call it the lowest platform. I'm guessing this is the lowest in a y-axis direction, because remember, for graphics, 0, 0 is in the top left, and your y-axis gets higher as you move down the screen, which is obviously not what any of us learned in high school math. So the lowest platform, as you move up into the negative space, right, as Dash is climbing, your y-axis value is going to keep moving down, lower and lower and lower and lower. So this lowest platform could actually be kind of the highest platform from a naive player's perspective, which is a little bit reinforced by the name of this variable, the tallest platform height. I'm going to scan the chat and see if Khan has told us anything about this. Not yet. But oh, we've got some questions about whether or not Flame has a particle effects system. And Damien answers, yes, there is a particle component, so you can generate multiple particles. I've not played with that, but Damien has apparently. Great. All right. So this is the update method. So every frame, we're basically kind of seeing here, is this, you know, the furthest away platform that has been generated, does this meet a certain criteria? Is it greater than the screen bottom? And I haven't quite worked out what that really like means yet. I have a theory, but we can see here that this is when a new platform is added, and it kind of gets, you know, some pseudo random. I love that it's called semi-random. Essentially a pseudo or semi random location. So nice. And then, oh, this is when we increase the score. So it's every platform that's generated increases the score. Okay, cool. And then some cleanup. Maybe add an enemy, maybe add a power up. Nice. All right. And then we can see some different levels here. I've actually not played the game long enough to make it to these other levels. Or maybe I have. I've seen broken platforms and Noogler hats. I think I've maybe even seen rockets. Oh, I've seen an enemy too. And I thought the game crashed because I ran into an enemy that I didn't notice and I just lost. I was like, what happened? But I think it was an enemy that I saw. All right. Some more logic here. I think we probably don't have to worry about this for today. Configure. What is this doing? Well, I don't even know where that's called. Okay. I think we're kind of ready. Let's do it. The time. So what I want to do is add UFOs. We're in outer space here. So I want to add UFOs periodically that shoot lasers at Dash. And not only do you have to land on platforms, but you will have to dodge the lasers. So we'll see how far we get. If it's not completed today, Con and I are planning on continuing the effort in our live Boring Show episode that we will stream next week on Tuesday, I believe. So we've got 2 cracks at this feature. So let's see how far we get. First, I have already grabbed some assets, and let me go to my desktop. And I keep a really cluttered desktop. I apologize, folks. But there's 3 assets that I'm going to add here, and 2 of them I actually got from Con. They're going to be released for everyone to use later this week. We just had the exact same idea of what to use. So there's these 2 UFO assets. with the lights on and the lights off. And I'm going to add these as a like a sprite component. So they're going to be kind of twinkling with the lights toggling between on and off. And then I've got this laser asset, which I think is going to stick out nicely against the blue background of the game. It does not stick out so nicely against the white and gray background of macOS's Finder. Someone asked, does Flame run on the web? Sure does. Yes. Great question, though. All right, let's start adding these. So the first thing that I need to do is drop these assets into the asset folder. So I'm going to grab them all, and I'll switch to my dev directory and go into my Git folder, Flutter, Code Labs, Flame building Doodle Dash, finished game, assets, images, game, and in here they go. Yes. All right. They are now loaded. Okay. So nothing new is happening here, but the first question I think we need to ask ourselves is how, like, when do we want to add a UFO? There's these different levels. I don't think I'm going to play with the levels because I don't want to have to, like, you know, maybe it would actually only make sense to add these in the enemy level or something, but I don't want to have to play to level 5 before I can test my new feature. So I am going to, I think, just add them all the time. And then maybe later they could be balanced. Maybe they could be level 6 or something. So in this update feature of the object manager, which adds things for Dash to interact with as she's moving through the universe, the Flutterverse, as it were, we can already see where new platforms get added. And then there's these conditional things. Maybe add or clean up platforms, maybe add enemy, maybe add power up. And I'm guessing these maybes are like, are you in that level? But I'm just going to add it, you know, pretty much every time. So I think in this if statement is where we can put code to add a new UFO. But first we need to create the class for a UFO. So this is adding platforms. So I think I'm going to look at other platforms. And let's see here. What else do we have? There's widgets. I think this is kind of like menus, the score, different things like that. What's in sprites? Oh, a platform. Aha. Oh, and there's a laser file. A little bit of playing around I did earlier. So this enemy platform has. Let's see how all of this works. So they've added they've created a base platform class. And I had to kind of spend a little time understanding this. I'm going to help everyone else understand it in case the feature you want to add for the Doodle Dash challenge is something about platforms. So this is a super type for all platforms, including enemies. This class adds a hitbox and collision callbacks to all subtypes, and it also allows the platform to move if it wants to. All platforms know how to move and have a 20% chance of being a moving platform. Now, this is the interesting part. Well, that was also interesting, but this was the confusing part, this generic. It's like, what is T? Well, T should be an enum that is used to switch between sprites, if necessary. Many platforms only need one sprite, so T will be an enum that looks something like enum, and then just, there's only one value. So that is kind of the general idea of this platform class. And now if we scroll down, we can look at a specific instance of it. So a normal platform doesn't break, you know, it doesn't do anything fancy. So it only exists in its one state. So we see here our normal platform extends platform, and it has its kind of singleton almost. It's not really a singleton, but it's just one flavor. It's like an ice cream shop that only has vanilla flavor of the normal platform. And oh, there are different sprite options. I actually don't know how this works. This is really interesting. I haven't noticed this yet in my previous reading of the code. Now, one thing I did see is this sprites map, or dictionary as Python developers call it. I know we have one in the chat today. So this sprites map is a map of our T object, so our state enum, to the correct sprite. And there's only one key and value in this one. Completing this feature is the current variable or class attribute. And these are coming from, by the way, the sprite group component class, which is why we didn't see them kind of talked about too much up here. But if we scroll back down, we'll see our sprites map gets set up, and then current is obviously, current points to a value from our state enum. And that is how Flame knows which of all of these sprites to load. And then for us as a Flame developer, all we have to do is change the current class attribute and we'll be ready to go. Okay. Sorry, I just got a message from Khan. I don't know. I think she's continuing to watch, which is just great. Okay, so that's how the sprite sprite group component, what was it called? Yeah, sprite group component works. Let's look at another one that actually has different states, like the broken platform state. So this can either be cracked, which threatens to break, or broken, which is delivered on the promise. And we see now the sprites map has 2 keys and 2 values. So it's like, God, the tooltip, just the bane of my existence while streaming, let me tell you what. The cracked state leads to the cracked ping, the GIF or sprite, and the broken state leads to the broken image. And then current, right, it starts as cracked. Now this size thing I think is going to be interesting later, because I'm not actually 100% sure what the size is of my UFO assets. So I might need to do something clever with that, or like work out what the right size is. Anyway, I think we're ready to add our UFO. Now the UFO is not like really a platform because you can't jump off it, but I think I'm just going to add it to this file for now so I can reference the other code in here. So I'm going to have a new enum, and this will be called our UFO state. I think that's it. And remember, our only state for the UFO is whether the lights are on or off. So we're going to have one called lights and maybe one called dark. So it's either dark or it's lit up and the lights are on. I think that seems pretty reasonable. And now let's add the class. It'll be called UFO, and it extends platform of UFO state. I think that's right. I'm going to scroll up and remind myself. So it takes us superposition. I love when programming offers really funny variable names. This happens a lot where just innocuous, totally normal code is read aloud, and it's quite funny. Superposition is a quantum physics thing about electrons and their probabilities and whatnot. And we're in outer space talking about UFOs, so breaking the Flutterverse. Khan assumed a superposition for the entire announcement video for 17 Days of Flutter. So this is, I don't know, I always just really get a tickle out of those things. Anyway, in onload, we see this is where Khan and Eric were setting up the sprites map and establishing the current value. So I'm going to grab this as well and add this to a method that I haven't even set up yet. Onload. Nice. We've even got a snippet for it. So our sprites map is of UFO state to sprite. And then we have UFO state with the lights are on. And this goes to, what did I call it? UFO, don't remember. It's called UFO-lights. Okay. UFO lights. No, we don't need the $sign. That was the issue. I was like, what's going on here? This needs to be async. And then we have another one. This was UFO that's dark. And this sprite was UFO-dark. Okay. And our current, let's maybe, should we like randomize this? I don't want them all kind of blinking on and off in perfect synchrony, like there's some kind of hive mind, though they're aliens, so a hive mind wouldn't be the craziest thing. But let's have them kind of all twinkle back and forth at their own pace. So we saw there was some randomness here, and I'm going to make use of this. But I'm going to put it in the constructor. So first of all, we're going to have a, how do we want this to work? Let's make a random object that we can hold on to. So this will be random. Oh yeah, no, not next bool anymore. And what I think I want to do, I don't necessarily care as much whether or not they start on or off. I care about randomizing the rate at which they turn their lights on or off. So maybe we can have an amount of milliseconds that will be the length of each phase for a given UFO. So we could have our lights interval, maybe we can call it, and we'll have to save this as well. This will be an int. It'll be lights interval. I guess we can underscore this as well. Oh, I've moved off the correct screen over here. There we go. Oh, Khan was answering a question. I'm going to scroll up and find the question. And oh, here we go. Samir asks, is there support for X input using Flame, Dart, and Flutter APIs on PC and Mac platforms? I'm not going to lie. I don't know what X input is, but Khan seems to, because she says, great question. I'm researching the same thing right now. There's a Flame gamepad package, but it only supports Android at the moment. Ah, okay. So X input, I wonder if this is for controllers. Sure seems to, with this mention of gamepads. Umar Janov asks, what kind of game are you hacking? Great question. Khan and Eric, as part of the lead up to Flutter Forward and in their season 2 of Learning to Fly, made a Flutter and Firebase themed port of Doodle Jump, I believe, is the origin game. And ours is called Doodle Dash because Dash or Sparky, which is Firebase's mascot, are dashing through the multiverse. And we're adding a feature to it. So I'm going to have some UFOs appear and shoot laser beams at Dash because the universe is a scary place. And that's what we're doing. And this is all part of the Doodle Dash challenge, which I really am now realizing I should add as a banner. Let's do this. Doodle Dash challenge. Add the banner, and now show it. There we go. That's it. So when you all do this yourself and add something to the game and then tweet it at us, make sure you use this hashtag so everyone can see your awesome feature and tell you how great you did. It's really important. Okay, we've got our lights interval here. And this is going to be a random.nextInt, I think. How fast do we want this to go? Maybe like a second range, and then it'll be like between a half a second and a second and a half or something. So if we do this, then this will be, assuming these are milliseconds, let's make the variable a little bit more clear. Lights interval in milliseconds. So this is now a floor of 500 milliseconds, and then up to 1,000 more milliseconds above that. So somewhere between a second and a second and a half. And then we'll need to know when, we don't need this line anymore at all. And we need to know when we came into existence. You know, what was the last time the light changed? So we can simply store our last light change as datetime.now. And the last light change will be late, this is a date time. And there we go. All right. Now, oh yeah, this will be UFO state.lights. Sure, the lights start on. Okay, so now we get to say if datetime.now.difference, right? And we compare this to the last light change. If that is greater than, and this returns a duration, great. So our duration is going to be the number of milliseconds that we have our interval for, which we stored here. So if we have been, wow, what a long line of code. Holy smokes. Oh, I don't need to wrap this in a duration every time. We can wrap it in a duration here. Hello. And now this becomes a duration. Well, that's nicer. Then we don't have to do all this. Line of code, shortenified. All right. So if the current time minus the last time we changed is greater than how frequently we should change, then it's time to change the lights. So for here, we'll say current becomes the opposite of the current value. So we say, we can use a little ternary here, tertiary, whatever it's called. So if our current equals UFO state.lights, then we'll set it to UFO state.dark. Otherwise, we're setting it to UFO state.lights. Okay? And the last thing we have to do is note the date and time in the captain's log. So our last light change now becomes datetime.now. All right. We have a UFO class. If my calculations are correct, it might work. Oh, someone is starring things for me, and I think it's gone. So I'm going to read some starred questions. Raphael asks, hello, what is the Flutter and Flame versions being used in this game? The latest. Good question. When to use Forge 2D and when not? Sheik asks. Khan? Did you encounter the boundaries of when you'd need to step into Forge 2D land? Forge 2D is a very cool open source tool, which Flame integrates with. Actually, I don't know if it's open source. I take that back. But it's a very cool tool to generate your own assets for these kinds of games. But I'm not going to lie, I don't really know. Oh, here we go. Khan answered the question. She said, from working on Doodle Dash, the out-of-the-box collision detection and physics from Flame was perfectly fine. But there is such a package. All right, so the exact boundary of when you graduate from Simple Sprites and find yourself in Forge 2D land, unknown as of now. But we'll get that answer as a team. Oh, this is an interesting one. Gabriel says, are we going to complete the method configure in the Object Manager file in this video? Well, we weren't going to until you asked that question, because I didn't even notice the method. But now we're going to look at it. Wait a minute, maybe I did talk about this method. But all I said was, I don't know what this method does. What does configure do? Who are you? Oh, it's not called in this method. I wonder if this is just called by Flame. What are we in? We're in the Object Manager. Okay, what is the base? What is the superclass of Object Manager? It's a component. So does component have a configure method? Configure. Doesn't appear here. And it doesn't have a superclass. All right, where does configure get called? Oh, in the game, we call configure. Oh, I think this method might already be complete. I think this is setting the size of the window. Yeah, this seems complete. Well, oh, the size was set internally, but this is setting the difficulty level. Oh, right, because on the loading screen, there was a difficulty slider. And then we check the level up, so we set the level and the difficulty. Yeah, I think this method's complete. I'm not sure if there is anything to add to that. Artur asks, will you provide a stable version of Impeller at Flutter Forward? Stay tuned. There are Impeller updates coming in Flutter Forward. And if you are really invested, you can read the source code, all the commits about Impeller, and probably work out what the changes are yourself. But that is a lot of work, honestly. So it's also fine to just wait until next week and hear it live. Okay. Oh, what kind of extension do you use? Synthwave 84. Theme Synthwave 84. It's a really nice theme. I agree. You've got good taste, Salim. Okay, we're back. So we have added our UFO class, which has an issue. Random must be initialized. Yeah, you are also late, my friend. Okay, now we're good. We added the UFO class. Now we need to use the UFO class. So if we switch to Object Manager, we'll find the spot where earlier I said I was going to add UFOs. And that was wherever Con and Eric decided it made sense to add platforms. And have I worked out exactly what's going on here? Not at all. But I'm hoping this makes sense. So let's see what they've got going on here. They've got generate next Y. So this is going to be the height of the thing for us. And then generate next X, which of course will be the kind of left-right position of the platform that they're generating. And now this also takes a platform width. Let's see what's going on here. So this just makes it not clip off the left or off the right side of the screen. So the center has to be, the center of or the position, I don't know if it's the center yet, of the new platform, if it's 100 pixels wide, it has to be with, 100 pixels in from the right or in from the left. That makes sense. All right. So next, that was generate next X. And so then this is, I think this is comparing previous. Yeah. This kind of ensures a nice spread of the platforms is what I'm seeing here, because we're worrying about overlaps and whatnot. That's kind of interesting. I wonder what imbalance happened before this code was added. Maybe there were times when it would maybe just kind of generate a bunch of platforms right on top of each other and you couldn't make it there in time or something. That's interesting. I'm just making this up, of course. So anyway, we're back here, and then there's a semi-random platform method. Let's see what this one does. Semi-random platform takes a position as a vector, and it figures out, interesting. So it looks at our different states the game might be in and adds different kinds of platforms based on whatever is going on in this special platforms map. I wonder if that is derived from the difficulty slider. That could be true. But anyway, this just returns a platform. So the semi-random platform, and then there's this probability generator, probgen, generate with probability, which basically houses a random number generator. And you give it a percent, and it gives you a true or false. Okay. I love it. So in semi-random platform, Oh, it's called again here. Is this in on mount? Yeah, okay. So this was our initial game state. You know, you have some platforms to go with right away before you even need new ones. But I'm just going to put them here. So this will also mean there'll be no platform, no UFOs in the opening screen. Not until we get to whatever this condition is. So let's say here, oh yeah, add. This is the thing. This is a magic flame method that actually inserts your object into the game. So let's say if, and we had our probability generator is floating around here in this class. So we'll give some probability because we don't want to just totally pepper the game with, you know, UFOs everywhere. So we'll say if probgen dot generate with probability. Actually, let's find out how many, let's say every time, let's see how many UFOs this makes. So if, this is essentially saying if true, if my understanding of the code is correct, we'll add a new UFO. So I'll add a UFO and I owe this a position, and I'm just going to generate a position the exact same way that they generated a position before. So this will be our UFO Y, we'll call it. That's not how you type. Our UFO X. Well, UFO X honestly just sounds satisfying. It's like a X-Files thing. UFO X. So this is our UFO X and our UFO Y. And, oh, what's the issue here? You have too many positional arguments. Oh, did I make it? Is it a named parameter? Oh, position. Yeah, okay. All right. We're moving along. So, ProbGen. We've added our UFO. Oh, there was a thing about them having a 20% chance to move. I don't know. I don't remember what that was. Or actually, did I ever work out how that happens? It's probably in the platform file. Do we care if the UFOs move? That's a thing UFOs do. Speed. This could be the movement. Oh, here we go. Oh, it said 20% is moving. Yeah. This would be 20% of them move. And so then is moving, oh, there's a move method. Would you look at that? The move method says if you're not moving, don't go anywhere. Otherwise, do some moving. Okay? And then move is called an update. Wonderful. Just great. All right, let's run it and see what we get. While this builds, oh, look at the chat. Oh, Damien says, maybe a sprite animation using both images will be better for this. So the lights on or off will be always animated. Huh. That's very interesting. I don't know what to say about that. Maybe it's true. Maybe that is what we should do. All right, I'm gonna hide this, and all right, this challenge logo isn't going to obstruct too much of the game, I don't think. Oh wait, I know how to make it obstruct none of the game. Bring the bottom up above the decal. Okay, here we go. So starting is no, I was dash last time, so this time will be Sparky. All right, I'm jumping, and we've got UFOs, and they are not. Oh, they were. I don't know how much you could see it. The lights were not turning on and off. Yeah, no. Oh, whoops. I screwed that up. Okay, so nope. The lights are not moving. Some of the UFOs move. We saw one moving to the right. There's another one moving there. But boy, the lights are not twinkling. Okay. What did I do wrong? Let's review here. Where's our UFO class? UFO. There we go. Light, dark. Yeah, I didn't like use the lights decal twice. Let me make sure the images are actually different. That would be a funny one. The images are different. Right, we've got lights on and off here. These are what I copied into the directory. So that shouldn't be an issue. Okay. I wonder if this is simply never firing. Let's print changing lights. I'm guessing we're never going to see this print. But we'll find out together. And it builds, and we're just gonna alternate every time. Today we're Sparky. Dash. Oh yeah, nothing printing. We don't even need to look at the game. This was our source of truth here, which is covered by the thing. But you can already tell because the terminal's not going anywhere, that it's not printing. So the datetime.now.difference last light change, if that's greater, why wouldn't it ever reach like 1.5 seconds? All right, let's first of all print, make sure these are the kind of interval that we think they are. I'm pretty sure they will be. And then let's print our difference here. We're just going to absolutely spam this because every single UFO is going to be printing these values. It's going to be just a mudslide of information that we cannot make use of. It'll be hard to make use of it. We won't know what's from which one, but we'll just see, like, are the values all obviously wrong or something? Okay, it's building. Back to Sparky and go. Okay, we've got some things here. So these intervals are correct. Intervals are looking good, but the difference is just staying really tiny. Why? Why? When it's like something is updating that value every frame, but we know it's not this one because we never get into the if statement. And what? Maybe this condition should be on the update method. Oh, I wrote it in on load. Nice. Everyone's saying it. It's in on load. Should be an update. Thanks, folks. I appreciate that. Well, I feel sheepish. Update. Love it. Okay, so we can get rid of these print statements now because they were very noisy. Here we go. Oh, right. So each UFO is only printing once. And I didn't even notice, because the onload is only called once, our stream of crazy info from the UFOs stopped because it stopped loading new UFOs. I wasn't even realizing like that should have just kept spamming if it was correctly in update. Okay, here we go. We're bouncing and they're twinkling. It's a pretty subtle effect. I'm not gonna lie. It's not exactly in your face, but it does exist. All right. So now I think it's time to start shooting some lasers. And this will be interesting. Okay. Kill the game. Good job, Sparky. You did it. Also, have not given any thought yet to whether or not this is an appropriate amount of UFOs or too many. But we'll figure that out later. Okay, so they need to shoot lasers. So I'm going to add, again, this should go in a different file. I'll clean that up later. I'm just going to add a new laser class, and we'll call it, what What do we want to call it? Laser. That's an interesting one. Class laser. No, do I have, you know, we saw a laser file from when I was playing around earlier. Does that still exist? It does. Oh, nice. Okay, we're just going to use this. And I put it in its own file. Okay, so a laser, I used a sprite component again. Why did I do that? Oh, no, a sprite component. That makes sense. For a second, I was thinking sprite group component. All right, so let's understand the sprite component. This, I'm going to switch over to the actual sprite component in Flame. And it's a position component that renders a single sprite at the designated position, scaled to have the designated size, and rotated to the specified angle. Great. And this is commonly used. Oh, this is a commonly used subclass of component. So this line is here telling us if you think you should be using a sprite component, you're probably correct. We're not like too low level or something. All right, and it takes a sprite and a position and a size. Yeah, these were the variables that I was looking at here. Position, angle, which is going to take some very hard trigonometry. I'm terrible at trigonometry. The sprite itself and how fast the laser moves. So these were my thoughts when I was looking at this earlier. Now, I didn't do anything with onload. That's interesting. Look at this wonderful code that I left myself. So, and then this is going to start moving the laser. Oh, that's right. I didn't get the laser tracking dash at all. I just wanted to see it move. All right, let's have the UFO shoot a laser. So in our update method, certainly not onload, we won't make that mistake twice. The UFO may, every tick, every frame, it might fire a laser at dash. So we'll say if, and we have our random object here, dot next int, up to 100 is less than, oh, I wonder if we have access to that prob generator. Do we have a game ref? Dot game manager is where it was, dot prob gen, hey, dot generate with probability. So if we, oh, what's the issue here? Oh, because I have to say with has game ref. There we go. Nope, something broke now. UFO can't implement both has game ref and, oh, platform already does that for us. No, that wasn't the issue at all. Okay, we're back here with probability, I don't know. Again, we'll just say if true, essentially. This is going to be a lot of lasers. Okay, that's too many lasers. So 10% of frames, they're going to fire a laser. Now, what's the issue here? Conditions have to have a static type bool. Isn't that what generate with probability returns? Yeah, it doesn't know something here. Does it know game ref? Something's wrong. No, it doesn't even know game ref. Oh, it does. Okay, dot game manager. That's fine. Dot probgen. Does it know this? No. Okay, probgen. I'm not remembering. Oh, it was on the object manager. Object manager. Is that a thing? Hey, there we go. Object manager. Okay. So 10% of frames, each UFO is going to fire a laser. And let's add, and this is the magic. Oh, I don't know if I need to call add on this component or the game object. We'll find out. So we're going to add a new laser. And I remember there was something that was getting me for a long time. I'm actually glad I worked on it beforehand, though Khan might know the answer here. I tried to set the sprite in onload and the lasers never rendered. And then instead, when I passed in the sprite, the laser is rendered. So that's why the constructor here requires a sprite, even though it's always the same one. This is surely not the most elegant solution, but we'll pass our sprite, and this is going to be the game ref dot load sprite. And we see this method kind of used all over the place. Con and Eric are using game ref dot load sprite kind of left and right. So we'll use it as well. And it's asynchronous as well, so we have to await that. And this takes game laser.ping. All right, what do you not like? Dynamic. Oh, I have to import the laser class. Laser is in sprites, so I'll open sprites.dart and I'll export laser. And now in platform, we still have to import. This is in sprites, so we'll just import all of sprites, but it's at its own level. Okay, so now it knows what a laser is. And you also need to be asynchronous, which means you return the future type void. All right, so we're adding a laser. It needs an angle and a position. And we are bumping up against the boundaries of what I've thought about. So the position, I think it might make sense. Remember, our UFO has a position. I wonder how well we can use that. So we'll just copy the position of the UFO. And then for the angle, let's start with 0 and see what that gets us. Semicolon. What's the problem here? This says missing an await for the future computed by this expression. Oh, that's probably add. Wait. All right. Oh, Khan says, so it turns out it's hard to debug the sprite loading issue through a screencast. Let's regroup on that. So I think she knows what's going on here, but it might be involved to fix. But we're adding a laser, and remember the laser is already moving. It's just moving to the right. It's not going to track dash at all. It's just moving to the right. But let's see if that works. And Khan, if you've got another answer up your sleeve, I anticipate an issue here that I don't understand. So I'm going to be dash this time. And we go jump, jump, jump. Uh-oh, no lasers at all. That wasn't the issue that I anticipated. Okay. So one question that I had was knowing that adding something to my UFO component was maybe a bad idea. Let's try adding this to the game. I'm just making stuff up. Okay, refresh the game. And Sparky this time. All right, here we go. Hey, we got lasers. Okay, so we were not supposed to add. Oh, the lasers are looking good, actually. Interesting. So when I played with this before, the lasers weren't launching from the UFO. And I just wrote the same code from memory, but apparently not with some bug that I had in the previous version. And I don't know what that bug was. Wonderful. Leche Elemental says, React Native rules. I love it. It does, honestly. React Native is great. You're not wrong. I've not used React Native a ton. I've used React DOM immensely. Wonderful tech. Great stuff. Okay. Well, we got lasers. Amazing. So now there's this angle parameter, and I'm guessing that this is in radians. which we should, oh, also this was just absolutely a crazy amount of lasers. So let's cut this by 10 again. So less lasers, and for radians, there are 2 pi radians per circle. That's their translation to degrees. So 0 would be, no rotation. That's just the rotation of the sprite, which we saw was kind of going toward the right in our, just in the design of the sprite. And if we said 2 pi radians, 3.14159, which is the extent of the pi digits that I recall. If we were to say like pi times 2, we should see the exact same thing. The laser moving to the right, but also looking like it's moving to the right. So let's try that real quick. And we'll jump. And okay, still a lot of lasers, but we can see that there was basically no change. We said essentially rotate the laser 360 degrees, looks exactly the same. If we do this, then I think the lasers will look like they're going backwards because they'll rotate 180 degrees, but they'll still move to the right. So let's just test this. Refresh. Sparky this time. Do you think Sparky is better at dodging lasers, being a ball of fire in the first place? Yeah, look at that. The lasers are now going backwards. Also, oh, hey, it's that bug. Oh, interesting. Okay, this is what I was seeing before. Look at how the lasers don't launch from the UFOs anymore. This means there's some larger hitbox. It's not rotating that sprite in place. It's rotating it around some other circle. Anchor point, maybe somebody says. Yeah, I think that's absolutely correct. I don't know about the anchor point mechanic in whatchamacallit? Flame. Let's grab the documentation here. Oh, I keep moving the wrong window. Okay, here's the Flame documentation. I was looking at, yeah, that seems big enough. I was looking at the docs last night, and let's see if we can find Flame Sprite, or no, Flame Flutter anchor point. I don't know if this is like a general idea you're talking about, or it's a specific thing. In Flame, anchor. Hey, there we go. Position component and sprite component, and here it's from position component. Okay, this class represents a position object on the screen, blah, 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 blah. The base, and it has an anchor which transforms how the component is rendered. Oh my goodness. Kingpin, you are a king. Knowing the anchor point thing off the top of your head. Incredible. So let's go back. Where's our laser class? All right, in the laser file, sprite component. This means we will probably find an anchor, which we can continue to track down. Hopefully there's an attribute here we can read the doc string of. There we go. Okay, anchor point for this component. An anchor point describes a point within the rectangle of size. And I believe that defaults to the size of the image. This point is considered to be the logical center of the component. This can be visualized as the point where Flame grabs the component. All transforms occur around this point. Yes, that's absolutely what we've been seeing. The position is where the anchor point will end up after the component is translated. Okay. The rotation and scaling also happen around this anchor point. All right, so I don't know how to make the anchor point like the dead center of it. That's what we want, so we can just kind of turn our laser in place. The anchor of a component can be modified during runtime. Wonderful. When this happens, the position of the component will remain unchanged. which means that visually the component will shift on the screen. Oh, okay, that's what oh, okay, I understand. So the position doesn't change, but because the relationship between the anchor and the position change, visually it moves. It will shift on the screen so that the new anchor will be at the same screen coordinates as the old anchor was. I'm not gonna lie, I did not understand that. We're gonna have to play with it more. Oh, Gabriel asks, is the laser going to track Dash through the game? I was thinking we would just calculate Dash's position and launch in that direction, but then not be like a homing missile, because that would be very hard to dodge. So it'll not like try to lead Dash or do anything. It'll just create something kind of moving in the right direction. And remember, Dash is always going up and down, so there's going to be some line that the laser is going on, and Dash is going to go above it and then have to go back below it again. So I think even with the lasers being fairly naive, it'll still create just a lot of chaos. All right, we're just gonna have to play with the anchor. I don't know. I don't really get it yet. It's a double. No, that's the angle. Where's anchor again? Oh, it's an anchor class. And oh, it's an enum. The best. Now I don't have to think about this at all. Well, what was the default value? Why wouldn't it have been center? What's our, oh, top left. Okay. Laser. Let's pass an anchor of anchor.center and see what happens. Restart. I forget which one we were last time. I kind of always assume we were Dash last time because that's what the menu starts on. All right, so our center thing, I feel like the lasers are maybe a little closer to the UFOs, but it is not correct. Even a little bit, honestly. It's quite wrong. Simran says, it's good to know I'm not the only one who doesn't understand the documentation sometimes. Simran, I hope I'm saying your name right, by the way. It's you and me. We're in this together, not understanding the documentation. Someone else might, though. They say the anchor should be on the top left if Flame uses Flutter coordinates. So, Ribar, do you know why the location, I mean, it's obviously rotating like in a circle around the top left point. And I'm just not sure how to rotate it without moving its position. So this is the answer we're going to have to figure out. Obviously, center didn't fix anything either. So my naive guess was not correct. David says, hey, I just joined. What are we developing? We are working on the Doodle Dash challenge, which is where you add a feature to Doodle Dash, which is a game that was written by Con and Eric from the Flutter team. Oh my gosh, look at this. The lasers are still going behind the game overlay. Look at that. The universe is always cooking. Even if you're not watching, it's still happening. This is a really realistic simulated reality. I love it. Yeah, so there's the famous game Doodle Jump, where some character just kind of infinitely jumps up. And Con and Eric made a Flutter-themed port of it, where you're either Dash or Sparky, which is Firebase's mascot. And the Doodle Dash challenge is adding a new feature to their game. So I'm taking a stab at it, but I'm bumping into the limitations of my understanding of Flame's anchor points. And this is where we are right now. The lasers used to actually leave, they used to enter the universe from the UFO's position, from its gun, I guess. And now, after I rotated them to understand the angle parameter, they don't appear there anymore. So we've got some troubleshooting to do. Okay, Kingpin again, coming in hot, says it has the top left position of the UFO, right? Oh, you're right. That's a great point, because this is what I passed in, and we read in the docstring. Okay, this is a really good thought. We read in the docstring that the position and the anchor can kind of influence each other. So in the object manager, where we add UFOs, here we go. Oh no, it's just in the UFO. This is where, okay, platform. Does platform take an anchor? Extends sprite group component. Does that take an anchor? Extends position component. So that should take an anchor. Yeah, back to UFO. So I think here we can say super, and we'll pass an anchor of anchor center, not a parameter, because it wasn't in platform right. So this will say anchor, anchor, and it'll be optional, and we'll pass it up the chain. Okay, that works. Except we now have a lint here, convert anchor to a super parameter. Oh, right, because it's going to be nullable all the way up. Huh. That seems obvious in hindsight. All right. Maybe anchor the laser as well. That was the first one that I anchored. I think we might be on something here with needing to anchor the UFO, but I want to make sure I didn't unanchor the laser. Yeah, it still says center. All right. Let's see if they now agree. The weird thing was, oh no, that's not that weird. I was thinking about how it was in the correct position before, but they both had top left and there was no rotation, so that made sense. Okay. Oh, that's it! Kingpin, let's go! All right, so we now understand anchor and position. And they are, because we rotated the laser, what is essentially 180 degrees, or pi radians, for those who like to feel smart. We now have lasers that look like they're going backwards. Yes, Kingpin, let's go indeed. Kingpin, you are so important to the success of this stream. Don't go anywhere. Now we get to try to rotate the laser the correct degree. So we're going to need to determine the, oh no, yeah, this is trig. Oh boy. Oh boy. Never do math on stream, the kids say, and here we go. So when we shoot a laser from the UFO, which is in platform, very confusingly, this is where we shoot a laser. This hard-coded angle is nonsense. We instead need to figure out the relationship between ourselves and dash. And we can say GameRef dot player. Okay, doesn't love that. That's apparently, oh, it is a thing. Okay, what do you, GameRef dot player is a player. Okay, is this dash's position? I don't know. What is player? Who are you? Player, yes, this is one of our files, and it's player state. Nice, this is gonna have our Sparky or dash. Oh, and all the keyboard. Wait, you can press keys to jump? I thought you just jumped when you hit a platform. I don't know how this game works yet, fully. Oh, to cheat. Oh, I love stuff like this in game development. Nice. Oh, it's just, okay, it's keys to go left and right, not to jump. I just I saw the jump method, which is commented out because it was just a development hack to test things. And I thought, what? But okay, so the keyboard is just an alternate way to play. Have I been pressing the keys the whole time? I probably have. Goodness. All right, the player is Dash or Sparky. That's what's important. So they probably have a position, and they do. So we can get the vector between us and them. So our position should be a vector 2, right? It's a notifying vector 2. What? What's a notifying vector 2? It's just a vector 2 with change notifier. Wonderful. Okay. We're back to platform, not player, not Doodle Dash. Let's close some of these files. Platform, here we go. So the position of the player minus, can you subtract vectors? Our position is going to be our laser vector. We'll just call it this. Thinking out loud in the most cumbersome way here. Yes, this is a vector 2. Great. So now I need to be able to translate this vector into an angle. And do I have like a place to draw? Damien said, just 1 minute ago, Damien, you said, I think you're adding the laser to the top left coordinate of the UFO. Well, I think I was, but now we're adding it to the center, I think, because the UFO's position, or sorry, its anchor has been updated to center. So I think that we have moved past that state of affairs. But if you disagree, please let me know. All right, I need to like a place to draw. Draw.google, is that a thing? No, it isn't. Google Draw. I thought it was a thing. You could just draw things. There we go. Okay. What are the tools that I have to my, align, that'll work. Okay, so let's say, let's insert word art, that's sure. Yeah, it'll say dash. Okay, so let's say dash is right here. And then, no, dash is jumping. So dash is up here. And then we're gonna also insert more word art. This is really elegant. That's the UFO. So we will have just calculated. Now I'm gonna add a line. Can I make this bigger? No, it's not helping. Simran says they would anchor it to the center right. Simran, can you say more about that? I don't know why we would do that. But that's interesting. I'd add anchors. Oh, someone else says I'd add anchors or lasers to the center left. I don't know why we would do these things, but I would love to hear explanations from both of you on why you think, you obviously have kind of the same idea, right? Center right, center left here. I think you're thinking the same thing, but maybe you just prefer the other side of it. But why we prefer those over the center where it is right now. I'm very curious about where your head's at. All right, so I'm going to add a line, and we will have just calculated, how do you add lines? Arrow, sure. So we will have just calculated basically this vector. And we need to know, and then there's going to be, this is kind of the way it shoots natively. If we pass 0, oh God, I can't believe I'm doing this. This is my worst nightmare. Can I make a curve here? Okay, here we go. And then, no, that's, oh God, what a terrible tool. How do we, yeah, curve. Bro. Oh, scribble, there we go, thank you. Okay, all right, so we need this angle. Now, I don't think we need anything more than SOHCAHTOA. So this is the hypotenuse, right? This is the hypotenuse. This is the opposite. And that's it, right? So sine is the opposite over the hypotenuse. Wait, which one do I even calculate here? I literally haven't done this in like 15 years. Right, that is the hypotenuse. Oh, right, and I know the lengths. That's the idea. That's the idea here. So let's say we've calculated that this is a vector of like 5 and 2 or something. I just have to give myself concrete numbers to think about. So let's say this is like a width of 5. It's good handwriting. And this opposite here, that's not a 0, that's opposite. So this is a 2, we're pretending. All right, so I think in this case, we would say this angle is sine, the sine of this angle is opposite over hypotenuse. Well, we could calculate the hypotenuse, but we don't know that one yet. So then there's the cosine. So, adjacent. We need that. So, katoa. So the tangent of the angle is the opposite over the adjacent. Yes, thank you. Thank you. Tangent, I agree. So 2 over 5 equals the tangent of the angle. I don't know what that means. Tangent of 2, well, that's 0.4, we know. So, no, wait, 0.4 radians. Oh, this is, I'm still not quite right here. So this is saying, am I going to have to like unapply this? All right, this is what I'm going to do to start. I'm not going to actually factor in Dash's position. I'm just going to pretend I've got this 5 over 2 thing going on. And I want to see what value do I have to put into that angle parameter such that we shoot the laser in this direction. Pretending Dash was there. People are typing things. Maybe someone's rescuing me from doing trigonometry. All right, Simran has said, anchor as center. Feels like the laser is coming from the side of the UFO and it overlaps the UFO. I get it. With center right, it would feel more natural as the game for users because it wouldn't overlap the UFO. Well, that is totally fair. But when Dash is to the left of the UFO, then we would need center left. And when Dash is like, in this situation, maybe we'd want, we don't really want center right. We don't want center left. We don't want center. We want, center top right, but with this precise angle. So I think you're onto something here. And we're going to have to play with that to see kind of how we can get it to render in a nice way. And I'm guessing that Louis, who was saying center left, basically had the same idea. They were just imagining when Dash was on the left of the UFO. But good thinking, and we do want this to not look silly. But first, we need to figure out how to tell it what way to go. So I want the angle to be, I think, the tangent of 2 over 4, but it also is going to probably be like negative that, because that would probably put us at this kind of angle. So we're going to need basically negative that. Let's try it. Also, I don't even know. Dart, calculate, tangent of, we'll just say tangent. It's probably somewhere in the math directory. The tan function. Nice. And we give it radians. Okay. Hold on to your butts. What movie is that, by the way? A little pop quiz for you Gen Zers. Extra credit, what actor said it? So we are gonna first bring in the, oh, math is already there. Who would have thought a video game already was importing the math library? Weird. So the tangent of 2 over 5, which is 0.4, and I think we need this to be negative. And I have no idea what I'm doing. Restart. Now it's not going to move in that angle, of course, because we would have to change the laser's movement code to honor the angle, which we're not doing yet. It might just point in that direction. Let's find out. Okay, we're jumping. Oh my goodness. It's pointed in that direction. Oh no, that's so great. I'm so happy. I did a trigonometry. Okay, now we need the actual value here. So the opposite for us was the y value of our laser vector. So this is laser vector dot y, and I wonder if vectors like have handy utilities for this. And then this is laser vector dot x. Now, are we going to need to invert the y? Because yeah, I think we are going to need to, because a higher dash is a more negative y value. Remember, we talked about that with graphics in the beginning. So I think we'll need negative y over x into tangent, negative that. That probably means we could get rid of both negatives. Oh, we're getting other trig ideas here. Someone thinks it's tan inverse, and then someone agrees with them. Saksham says, I think it's inverse tangent. Is that what I don't know the difference between the inverse tangent and a negative tangent. We'll see, because now this is potentially like dynamic code that will be kind of doing it correctly. So if I kind of had lucked my way into something that only worked for those hard-coded values, we'll see that pretty quickly. Okay, restart. And come back. Sparky this time. I think we were just dash. Jumpy jump. Please jump more. I want to get to the UFOs. Yeah, wait. Well, it's really hard to tell. Oh, no. Yeah, it's wrong. It's super wrong. Whoever said that it wasn't right, yeah, it's definitely wrong. All right, so we need some inverse tangent, A-tan magic. People think that and other people agree. Inverse tangent gives you the angle given a tangent value. Oh, okay, that's good. So A-tan? Is it as simple as this? There's so many people in the chat who know trigonometry. This is great. Yeah, inverse tangent gives you an angle given a tangent value. That sounds exactly like what we need. And then other people are echoing that. Jeff and Ryan agree with Saksham. Great. Okay, try it again. I'm willing to type almost anything you guys tell me, if it's some trig incantation. Okay. This is definitely a third level trig spell. Okay, so the ones above it are pointed down, and then, yeah. The ones below it point up. Dude, let's go. All right. Now, I love you guys. So the next thing, we have this angle coming in, and we need to not just apply this super dumb move to the right vector, but the correct vector based off the angle. So let's think about what goes in there. So I I think I need to translate the radians of the angle back into a vector, because that will just give us the x and y. Now, I don't really want to do that because I already had the vector here, so I'm just going to pass that in. An actual math person would know that this was redundant, but we've already seen that I am not an actual math person. And then laser vector is a little redundant as the parameter name to the laser. So we'll now call you, this was super required, a vector 2. Sure, we'll just call it vector. Movement vector. Movement vector. Great. And could be final, sure. Where did that even get used? All right, whatever. So we have our movement vector passed in. So this is just movement vector, I think. No. We're going to have to normalize the speed. Oh, that's going to be interesting. I think we're going to get radically different speeds if we just put in movement vector here. But I'm willing to test that first. Movement vector. Oh yeah, we need to say this dot movement vector. Of course, we're adding this as a brand new instance variable right now that was not previously a sprite or a flame thing. So this is vector 2, final, because you are not tracking the changing position of dash movement vector. And then we go back to platform and we called you now movement vector. All right. Is there a rotate method on vector? Yeah, probably. And I think that would be more handy than what I'm doing. Let's, oh, I killed the game. What a terrible mistake. Okay, I'm going to read more of the trig lessons you're all trying to teach me while this builds. Oh, I'm done. I'm rescued. Dash this time. Let's jump. Here we go. I think I'm going to put in that cheat code, by the way. Whoa, they're moving so fast, which we definitely expected. But they're tracking dash, and then they're just zipping right off the screen. Excuse me. And we're going to need to like clean these up. You know, you can see in the actual original code, they keep all of the platforms in an array and then they clean them up. You know, we are just littering the universe with these lasers, which, I don't know, the universe is a big place, I guess, but eventually we're going to want to hold on to those and clean them up. So we need to normalize this vector, and the distance of the vector is, going to come in completely different based on how far dash was from that thing at the same time, or at the time that the laser was fired. So if we simply shorten, I think we're going to make a vector of a fixed length based on the values that came in. So I'm going to make a vector of length 1 because a squared plus b squared equals c squared when they're all 1. Nope, that's not right. That's 1 plus 1 does not equal 2. All right, I'm going to make a vector of length 2. Well, how would that work? Let's go back to our drawing. All right, how do we normalize this? If I want hypotenuse to be 1, then I know 5 squared plus 2 squared needs to be shrunk to equal 1. That just feels, I wonder if there's like a normalize method. Let's look at the vector 2 class. Maybe it's going to help. Maybe it's going to help. Hello, vector 2. What have you got for me? Min, max, mix. Goodness. Array, 0, all, random. I don't want that. Set to 0, set from, splat. That's kind of a fun method name. Subtract, yeah, the operator's length. Whoa, we set the length? Is this set the length of the vector? A negative value will change the vector's orientation, and a value of 0 will set the vector to 0. I think if we set the length to 1, this is going to go and shrink it. Maybe. Length, if it's 0, return. Value over L. I don't know. Math square root of length. I think it's going to work. Length 2. Okay. Oh, norm. Look at this comment. Normalize this. Well, thanks. Definitely depends. Oh, wait a minute. This also could be important. I don't know. Before normalization. I don't know. I'm just going to set the length to 1. And this happens in the laser. So we're not setting the movement vector anymore. This is going to come in as a vector 2. And let's underscore this. And now in our constructor, we'll say movement vector equals movement vector dot length equals 1. That's a little bit of an awkward use of the cascade operator, but I think that'll work. We take the movement vector, we set its length to 1. Did that return a new vector, or did it modify the vector in place? Length. It's just a setter. So it modifies the vector, and then we save that. All right, people are giving me more math equations. The square root of x squared plus y squared equals 1. But we have to figure out like what to put in x and y there, right? So we got to square it. We gotta do things. That's heavy math on stream. You're probably right. I'm sure you're right. All right, let's rebuild and have an error. All right, yeah, you need to be underscore now. Okay, would just calling normalize work? Maybe. Well, let's try it. Let's try that. I kind of vaguely remember normalize being like you go to 1 or something. Yeah, that's also we need to use the cascade operator. Let's try normalize. Thank you, Joe. Joe Below. Is that really your name? Is that really your name? Here we go. Sparky. Here we go. Okay. This seems, I think, right. It's kind of hard to tell. Yeah. I think it's right. How are we going to make it to the next thing? Okay, good. We made it. Now they're, oh boy, these are slow. And there's still a ton of them. Just a massive amount of lasers. Way too many. Okay. This is really exciting though. Look at how games come together. And then when it finally starts to work, it's just incredibly fun. Great. Normalize. Amazing. So, because they were all moving the same speed. The speed was too slow, but they're all moving the same speed. So let's make them move 3 times faster. So now we'll say vector 2. This is going to be funny. There's probably another better way to do this too. The x times 3 and the y times 3. Okay. Restart. Dash. Jumpy, jump, jump, jump. Okay, this is a decent speed, I think. This is going to be tricky to dodge. We need way less of them, though. Or maybe not less. Well, we need less UFOs, potentially, because remember there was that point where we're like, we draw UFOs as just if true. So that's a lot of UFOs. Okay. In our object manager, where we added UFOs, we have a probability of adding them as 100. Let's make that 20. And let's, what was I going to say? Change the percentage of lasers. That's what it was. So that's in the UFO class, in platform, where it shoots. But we've already put the minimum, oh, double. Incredible. 1/10 as many lasers. I think we're good here. Oh, do a random speed, Damien says. That's kind of cool. I like that. Some laser sprite rotations seem not right, Daniel says. This is fairly tricky because when the laser launches, its angle immediately becomes wrong because Dash is moving. And I'm trying to like look at that really closely and see if any of them are wrong. But I don't know. I'll keep looking at that. So random laser speed. I like that. So the laser. Oh, we had a velocity here. Oh, look at that. Well, obviously we'll just multiply this by velocity. And then we can pass in the velocity. So, okay, yeah, we set that. That's good. So now, when we make a laser, we will add a random velocity. And this will be, yeah, we have a random thing in the UFO. We're in the UFO, right? It has a random thing? Yeah. So random.next, double, I guess. And let's cap this at like 4.0. Oh, that's not how that works. It gives us a double between 0 and 1, and then we multiply by 4. All right. Okay, Daniel says, can you change the render position of the laser so that the laser is behind the UFO? That would be good. That would be good. I think we're going to ultimately save that. The actual collision detection, which Flame makes so easy. We're going to save some of that tidying up for the live boring show next week, because I think that we're at a great breaking point here. As soon as this works and we're getting a nice amount of lasers. Oh, I'm going to add that jump in. That looked really handy. Player, jump, here we go. So we can just press arrow up and we jump. That's going to really improve our developer experience. But we restart again. We switch over. I start and I can just up arrow. Oh, that's nice. Look at this. Look at this. Okay, not enough lasers. Wow. I wonder if this method must actually not work with values that small. Numutils. So next int, oh, we take a double, but then we're generating ints. So values below 1 ain't gonna work. So for this, I think what we need, let's say, let's save our random double equals random dot next double. Next double. Next double. And then we will multiply this by 100. And now I think we say if random double. What are you? Oh yeah, I need an equal sign. That's really important. So if random double is less than the percent, it might work. I don't know. If everything breaks and there's no anything, then we know that I didn't do it right. All right, looks like there's about the same amount of platforms. There's our first UFO. It didn't shoot at us. That was a little stinky. Is there less platforms? I might have. Wow, there's really very few UFOs. Okay, here we got some. Maybe we were just getting unlucky. All right, 3 in a row. But they're not shooting. I have not fixed the... all right, what's going on here? Well, I didn't save the file. I didn't save the file. Classic mistake. Sparky, get in the game! Sparky. Hey, Sparky. Shoot at me. Shoot at me. Come on, man. These pacifist aliens. Okay. Let's think. What did we write and does it make any sense? In the UFO class, where it maybe shoots. We said with probability 0.1. That's what we passed into the method. So 0.1 is appearing here. Then we generate a random number between 0 and 1. And we multiply it by 100. This is going to make values that sit under 0.1 extremely rare. I guess 0.1 was just always a bad value. Let's go back to 1%, but that's what we had before, and there were just way too many. I'm not actually 100% sure what's going on here, but I am going to cheat to find out. Okay, there we go. All right, let's study. Oh yeah, the random. Oh, my random laser speeds was also a little funky. Okay, so they're pointed the wrong way. I think maybe they're tracking. I think they track the position of Sparky when they're fired, but definitely some of them are going backwards. Is it all the ones going to the left are backwards? Let's get to the left ourselves. Yep. If the lasers are going to the left, they are backwards. I wonder if that's what the person was saying. I'm going to scroll back up. Oh, more people are saying it. The bullet's image coming from the right should be mirrored. This was detected by y'all's keen eyes as many as 5 minutes ago. Someone else, Ryan, says it's because ATAN's value range is from negative pi over 2 to pi over 2, 90 degrees to negative 90 to 90 degrees. All right. I'm going to figure out what that means between now and Tuesday when Con and I will resume working on this on a live boring show. Streamed at about the same time as this, but on Tuesday. And we will pick up where I am currently leaving off. We will get these lasers to point the right way. I just put my display to sleep. That's not ideal. We will get these lasers to point the right way and look at collision detection as well, so that when Dash is bumped by a laser or Sparky. Oh, I wonder if Sparky should have a different reaction. No, that's too much. When either of the main characters is bumped by the laser, they lose because that's not what you want. And hopefully we'll wrap up the feature and have our submission to the Doodle Dash challenge. But folks, this is the game that Con and Eric have been building. And this is the Doodle Dash challenge. This is the code base. Hopefully you learned a bit about how it's stitched together. It's really quite well organized. I have to give a shout out to Brett Morgan, who also I know helped with the code a lot in this game. He is the mastermind behind the Code Labs and Samples repositories. So I know he played a role in helping this code be so clean, but all three of them deserve a ton of credit. And you know, this is a great starting point to add new features to the game. So the Doodle Dash challenge, when you've got a completed feature that you want to show off, please tweet it at us, use that hashtag, and tune in on Tuesday as 17 Days of Flutter continues with a live boring show episode hosted by Con and myself, where we will finish this new feature. Folks, have a great weekend. I'll see you all then.